Good morning, dear students. Today we will start a new topic that is called hyperbola, and this is the topic what is important, and also another point I would like to say is that this is the last topic of the conic section. In the series of discussion of conic section, we have discussed first the general conic section, then we discussed parabola. After that, we discussed ellipse, and this is the last portion, that is hyperbola. So, dear students, before I proceed, could you please confirm that you are able to hear my voice very clearly and able to view the screen properly?
Yes.
Okay, great. So now, if you recall that from the definition of any conic section, so we discussed that a conic is nothing but a curve traced out by a point in a plane, so that the ratio of the distance from a fixed point of that variable point and the distance of that variable point from a fixed line is a constant. Now, first we saw that if the constant, that ratio is a constant, then it is a conic. Later we saw that if that value of that constant is equal to 1, that conic is known as parabola. It is a specific type of curve. And when we say it is the constant value is less than 1, it is an ellipse. Okay. Now today what we are going to discuss when this ratio is actually greater than 1. And then we call the curve that traced out is hyperbola. So dear students, so what I can say in the introduction is that, a hyperbola, let me read out first. A hyperbola is the locus of a point P which moves in a plane so that the ratio of the distance from a fixed point S and its distance from a fixed straight line, okay, is greater than 1. And here is one assumption, that the fixed line is not passing through the fixed point S. So dear students, so if I write down the statement, whatever I just said is something like this. So I read it out, what I just placed in front of you is that a hyperbola is the locus of a point P, okay, which moves in a plane so that the ratio of the distance from a fixed point S, okay, and its distance from a fixed line, straight line, subject to the condition that the fixed straight line is not passing through the fixed point S, is greater than 1. So what we get here, dear students, SP by PM, that is S is the fixed point. We will see this is known as the focus. Okay, we have discussed this thing for the other two type of conics. And you see this is a straight line. Okay, and if we name the straight line as D1, D2, okay, D1, D2 is a fixed straight line, and a distance from a point, variable point P to this line, to this straight line, that is a perpendicular distance, is PM. So PS, SP by PM is greater than 1, then we call it as a hyperbola. And that fixed straight line is known as the directrix, as you know, and the fixed point S is known as the focus. Now, as we discussed in the other cases also, first we need to look into the different forms of hyperbola. The first form what we are going to see is that it is a general form. General form gives us a very good clarity about understanding the derivation. So that is why it is very important to discuss on the general form. However, general form is not widely used. What is widely used is the standard form. But as I said, still you should know the derivation of the general form so that it gives you a very good clarity about that what is hyperbola and how its equation is derived. Now, before proceeding to understand about the general form, let's first give a visual representation. And here it is, dear students. First, look into the diagram. What you see in the background, there is some watermark. That is actually it is the name of our institute, and which is, and I'm taking this note from the study material. So anyway, dear students, if you see, this is the coordinate axis, x o x dash, y o y dash, and this is the origin. Now, if you see that the curve is this, this is the curve as you see. Okay. Now, we took a point on this curve. We took a point P on this curve. And there is a fixed point S. And there is a fixed straight line D1, D2 as you see. D1, D2 is a fixed straight line. So the ratio of the distance, that is SP by PM, is equal to E. This is also known as E, that is called the eccentricity. Now, dear students, as it is a general form, so we are considering the focus is having coordinate h comma k. Okay, so that is a very generic point, h comma k, and the straight line d1 d2 and having an equation lx plus my plus n equal to 0. Lx plus my plus n equal to 0. Okay, so that is d1 d2. Now, let us assume the eccentricity of the hyperbola be E. That eccentricity of the hyperbola that we are assuming at E. And in this case, as we know, as we define, that E is greater than 1. So let me write it down, whatever I just said. Okay, now let us take a point P on the hyperbola with coordinate alpha comma beta. Now what we are coming is that we are going to take a point P and having its coordinate alpha comma beta. Alpha beta are variable, and as you know, when we establish the relationship that SP by PM is greater than 1, and after that what we need to do is that we need to replace alpha by x and beta by y to find the locus of the point. Correct, dear students? So the point is that let P be a point on the hyperbola with coordinate alpha comma beta and M be the foot of the perpendicular. Okay, drawn from the point P to the directrix D1, D2. So, dear students, so what you need to do is that, we need to find the equation of the hyperbola. That is locus of the variable point alpha comma beta. That is our target. Correct, dear students? Okay, now let's see how we are going to achieve it. To achieve this, first what you need to do is that, we know this relationship that SP by PM equal to E, and as you see that as SP by PM equal to E, definitely E is the eccentricity. SP is equal to E into PM, and that means SP square is equal to E square into PM square. It is the exact way of doing the derivation of the general form of the ellipse. Okay. So now what is SP? We know the coordinate of the points S and P. So it is very easy to find the value of SP square. That is nothing but alpha minus h whole square plus beta minus k whole square is equal to, what you see is that, E square into PM. PM is what? The perpendicular distance from the point alpha comma beta to the line Lx plus my plus n equal to 0. That we know it is nothing but L into alpha plus m into beta plus n divided by square root of L square in plus m square. Now as we make a square of the entire thing, so we get this thing, that L alpha plus m beta plus n complete whole square divided by L square plus m square. Correct, dear students? So now the point is that after that, if we make a cross multiplication, we get this in the equation 1. Correct? Now, dear students, what we need to find is that, we can rearrange that equation 1, and we get the the required equation of the hyperbola, that is just by replacing x by alpha by x and beta by y, and we get the equation of the hyperbola something like this. So this is the way. Let me first show it to you. So this is the way we derive the general equation of the hyperbola. Correct, dear students? Now, if you recall that in the very initial days of discussion of the conic section, we discussed that a general equation of second degree in x and y, okay, like ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equal to 0, okay, represents different conics, or pair of straight line, based on different conditions. So the conditions for that it represents hyperbola is that that delta, the determinant, if you recall, that should not be equal to 0 and h square is greater than ab. So let me show you this thing, with respect to the general equation of second degree, and here goes the statement. So so we see that the above equation 2 is of the form of general equation of second degree in x and y, like x square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0, where we get the following by equating the like terms of the above equation 2 and the general equation of second degree in x and y, that we find the value of delta which is not equal to 0 and h square is greater than ab. Okay, dear students? So in this way, we are able to derive the general form. We need to derive the equation of the hyperbola of the general form. But as I said, that what is widely used is the standard form. Now we are going to focus on deriving the equation of the standard form, and that will be the discussion for the next few minutes. So if you look into the standard form, dear students, so standard form will looks like something like this. First, let me give you a visual representation of the standard form. So how it actually looks like. So let me give you this thing first. Okay. So if you look into this in this visual representation very minutely, so this is the portion of the curve. Okay, as I'm making an arrow, this is actually hyperbola, and this is one focus, and this is another one. So there are two foci. Okay, and there are directrix. So this is one, and that is one. Okay, so we are going to discuss on all these things now. So if you look into this diagram very correctly, very minutely, what you see is that you see that NZ be directrix, S be focus, and as you know that E be the eccentricity of the hyperbola. So now we draw ZS perpendicular to the line NZ. As you see, we draw ZS, perpendicular to the perpendicular to the line NZ, that is the directrix. Let us divide the segment ZS both internally at the point A and externally at the point A dash in the ratio 1:E. Okay, and so what I wanted to mean is that, just a minute, let me give you so what I wanted to mean is that is that AS is equal to E into AZ. Okay, as you see here, dear students, that NZ be the directrix, S be the focus, and E be the eccentricity of the hyperbola. We draw ZS, okay, perpendicular to the line, NZ. Let us divide the line segment ZS. That is very important. Let us divide the line segment ZS both internally at the point A and externally at the point A dash. Okay, in the ratio 1:E. So what we get? We get AS equal to E into AZ, and similarly A dash is equal to E into A dash Z. That is coming from that internal division and external division. After that, what we are going to do, dear students, is that let's take the point A and A dash lie on the directrix, and let the point C be the midpoint of the line segment A dash, and A dash is equal to 2 into A. Now let us consider x-axis be along A dash and y-axis be passing through the point C. Then C is the origin, and definitely we get AC is equal to that value A, and that is equal to CA dash. Look into this statement and make a very clear understanding. Okay. So as you are not able to view the diagram, so I can do one thing. I can keep the version of the diagram once more. So here, so that you can make a proper understanding while going through the statement. So let me make that image little smaller so that you can follow it up here. Okay, dear students. So I repeat what I just placed it here. The point A and A dash lie on the hyperbola. Let the point C be the midpoint of the line segment A dash. Let the point C be the midpoint of the line segment A dash. And we are taking that A dash is equal to 2A. Let the x-axis be along A dash and y-axis be the line passing through the point C. Then C must be the origin, and we get AC is equal to lowercase a is equal to CA dash. Got it, dear students? Now what we are going to do is that if you look into this thing, it's quite clear that AS is equal to CS minus AC. So now let me show you all the derivations. That is very, very important derivations. Okay, and let me first explain you about this derivation. Look at here, AS equal to if you see AS is equal to CS minus AC. Okay, that means CS is equal to CS minus A, AC is A, lowercase a is equal to AS is nothing but E into AZ. We already derived. So what we get is that E into AZ is equal to CS minus A. So E into AZ, what is AZ? AZ is nothing but AC minus ZC, and that is equal to CS minus A. So E into AC is nothing but lowercase a. So E into A minus ZC is equal to CS minus A. That implies what? CS plus E into ZC is equal to A plus AE. Okay, that we got here, students. In the similar manner, if you see A dash S is equal to CS plus A dash C, and we get, that means CS plus A dash C is nothing but A. So that means what we get is that E into A dash Z is equal to CS plus A. As I read this statement, you can also look into the adjoining diagram and make a very clear understanding. Yeah, what Sir is telling, I'm able to make out of it. So then what we get is that E into A dash C plus CZ is equal to CS plus A. That implies E into A plus ZC is equal to CS plus A. And eventually we get CS minus E into ZC is equal to AE minus A. So dear students, if you look into that equation 1 and that equation 2, what we get is that CS plus, in the equation 1, we get CS plus E into ZC is equal to A plus A. And in the equation 2, we get CS minus E into ZC is equal to AE minus A. Correct? Now, we can solve these two equations. If we solve these two equations, we can find the value of CS is equal to AE and ZC is equal to A by E. Okay, so if we solve these two equations, these two equations, equation 1 and equation 2, okay, we get, that CS is equal to AE and ZC is equal to A by E. And these two are very important information. In the adjoining diagram, these are the two distances. These two are very important information in deriving the standard equation of the hyperbola. Now, what we get is the coordinate of the focus S is AE, 0, and the equation of the directrix NZ is X is equal to A by E. So these are the two important information we are able to get it. Okay, and as we get this information, the rest of the portions is going to be very, very straightforward. Why? Because we took that variable point P as alpha comma beta. Okay, we considered that variable point P as alpha comma beta, and which is on the hyperbola, and definitely SP is equal to E into PM. We know the coordinate of the point alpha beta, that is a variable point, that is alpha comma beta, and we know the coordinate of the focus is S AE, 0. Okay, and equation of that directrix NZ is nothing but X equal to A by E. Now, if you notice one thing, dear students, that here we found the coordinate of the focus as AE, 0. But while we discuss about the general form, there we took that coordinate of the focus as H, K, very arbitrary point, without any restriction. But here, if you see, the coordinate of the focus is AE, 0, means it is a point on the x-axis. And if you recall, in the general form, we took that equation of that directrix as Lx plus My plus n equal to 0, which is a generic equation of a straight line. But in this standard form, what we see is that we found the equation of the directrix as x equal to A by E, which is nothing but a straight line parallel to the y-axis. Correct? Now, dear students, let alpha comma beta be any point on the hyperbola which will satisfy the equation SP is equal to E into PM. So definitely what we are going to get, SP is equal to E into PM, that means SP square is equal to E square into PM square. Now what is SP square? We know the coordinate of the point S and the coordinate of the point P, so we can easily derive the SP square. And E square and PM square is also very easy to find it out. Okay, perpendicular distance from the variable point P having coordinate alpha comma beta to the directrix having equation x equal to A by E, and we get this one. After that, if we simplify, and we get this statement followed by this statement. Okay, and we are able to divide by a square into 1 minus a square because it is not equal to 0 as it is written here. So then, dear students, what we get is that we get that get to an equation alpha square by a square minus beta square by a square into e square minus 1 is equal to 1. Now, dear students, how to find the locus of the point alpha comma beta? As simple as that. We need to replace alpha by x and beta by y, and we will get the required equation of the hyperbola as I'm going to show you here now. Okay, dear students, so let me first show you, then you'll understand this is the equation of the hyperbola we have derived. Okay. One very important point is that x square by a square minus y square by b square equal to 1. That is the equation of the hyperbola. And what is the relationship between a and b? A and b are related through the eccentricity, and here it is b square is equal to a square into e square minus 1. Okay, so this is the relationship between a and b. So there are a few important points to remember, and that I'm going to discuss with you. Okay, the first point, what I'm going to show you is that, let me first place this point, followed by let me explain. So here is a statement. Since the equation of the hyperbola, only differs from that of the ellipse having minus b square is replaced by b square, it has been found that many propositions of the hyperbola can be derived from the ellipse just by replacing b square by minus b square. That's it. If you, as you know, all the attributes, different equations related to ellipse, in that one, you just replace b square by minus b square, and you will get it for the hyperbola. Why so? Because if you recall, what is the standard equation of an ellipse? That is x square by a square plus y square by b square equal to 1. And what is the standard equation of an hyperbola? The standard equation of a hyperbola is x square by a square minus y square by b square equal to 1. There is a minus. So hence, the statement that you can replace b square by minus b square in all these cases where you get for the ellipse. And now, like ellipse, hyperbola is also a central conic, and its center can be obtained by solving two partial differentials, and here it is. So hyperbola is a central conic, and its center can be obtained by solving the following equations. That is delta f delta x equal to 0 and delta f delta y equal to 0, where capital F xy is equal to 0 is the equation of the hyperbola. And dear students, as I explained in case of an ellipse, that delta f delta x is the partial differentiation of f, okay, with respect to x, okay, and keeping y as in the constant. That is what is called partial differentiation. Okay, so that is the second point. Now, dear students, we need to find the different attributes of the hyperbola. Okay, so attributes are there, but we need to know what are the name of those attributes. and that is the point of discussion of the of our next in the next slide. I'm going to discuss on those particular points. So what I wanted to say is that something like this, that there are different attributes of hyperbola. What are those different attributes that we are going to discuss now? The hyperbola, as let me first place this point. As I place all these points, let me discuss one by one. The hyperbola has two foci and two directrices. This is because the hyperbola is symmetric about y-axis. Quite obvious statement. The line passing through the foci is called the transverse axis of the hyperbola. So the transverse axis perpendicular to both the directrix and to both the directrix of the hyperbola. Correct? Okay. So transverse axis you understood. The line perpendicular to the transverse axis and passing through the center of the hyperbola is called the conjugate axis. Okay, so as if in context to our discussion in a diagram what you see earlier, x-axis looks like a transverse axis and y-axis looks like a if you recall this one, the previous page, then you'll find it out. Perpendicular to the transverse axis is the conjugate axis. The distance between the point of the intersection of the hyperbola with its transverse axis is called the length of the transverse axis. The distance between the points of intersection of the hyperbola with its transverse axis is called the length of the transverse axis. A line passing through the focus and perpendicular to the transverse axis of the hyperbola is called the latus rectum of the hyperbola. Now, as there are two foci, eventually there are two latus rectums. Correct, dear students? So these are the different attributes of a hyperbola. Now, we just need to remember one table, and if we recall this table, then it will be very easy for us to remember that what are the different attributes and what are their corresponding values. So now, depending on the selection of the coordinate axis, the standard form of hyperbola and its different attributes, may vary, and we are going to see it in the next, next slide by means of this table. So I'm going to share the table with you, and it is strongly recommended that you remember this content in the table, so that if you just remember one, the rest will actually eventually follow very easy manner. So as you see that center, so there are two different forms of hyperbola. The first form of hyperbola is x square by a square minus y square by b square equal to 1. And second form of hyperbola is y square by a square minus x square by b square equal to 1. In both these forms, the center remains the same at the point 0, 0. For the first form, the foci is at the point plus minus a, 0 because there are two foci. And for the second case, it is 0 plus minus a. For the first case, the equation of the directrix is x equal to plus minus a by e. And for the second case, second form, the equation of the directrix is y equal to plus minus a. In case of the equation x square minus a square plus y square minus b square equal to 1, the equation of the transverse axis is y equal to 0, which is the x-axis. Let me do one thing, dear students. Let me place the diagram here also, so that you can, you can make a very clear idea while going through these different attributes. Okay, so let me place it here so that you can make a proper sense of it. Okay, so let me quickly go through whatever the 3 points I said. So this is center. Okay, these are the foci. Okay, S and S dash having coordinates plus minus a comma 0. And if you choose the second form, but by the way, here I choose the first form actually, x square by a square minus y square by b square equal to 1. So x square by a square minus y square by b square equal to 1. Directrix is, in this case, is definitely parallel to the y-axis. So hence its equation becomes x is equal to plus minus a. Transverse axis is nothing but the line passing to the point a dash, and that is, we see it is the x-axis whose equation is y equal to 0. For the second form, it will be exactly, just replace x by y, y by x, and we get that it is x equal to 0. What is conjugate axis? Conjugate axis is nothing but perpendicular to the transverse axis. So for the first form, as the equation of the transverse axis is y equal to 0, so its equation of conjugate axis should be x equal to 0. Now, in the similar manner for the second form of the hyperbola, the transverse axis is x equal to 0 and conjugate axis is y equal to 0. So what is the length of the transverse axis in both the cases? It is 2a, and length of the conjugate axis in both the cases is actually 2b. Okay, length of lattice rectum. So these are the 2 points we discussed. So length of the lattice rectum, is nothing but 2b square by a. Okay, in both the cases. And very importantly, the relationship between that a and b is defined as b square equal to a square into e square minus 1. So these are the different attributes, dear students, and as I said earlier, that you need to remember this thing. And if you recall all these things, it will be very easy for you to actually, while you actually solving the problems, then you can just write down all these things, and it will be very, very easy for solving the problems. And you can only write down if you can memorize well. Okay, dear students, so with this note, I would like to conclude the class here now, because that is the most logical way of concluding this class. In the next class, so what I'm going to discuss about the equation of hyperbola in origin shifted form. Then we'll discuss about the parametric form and auxiliary circle. Then we'll discuss about the focal distance, alternative definition of hyperbola, conjugate hyperbola, asymptotes. Okay, and we'll find that point with respect to hyperbola, tangents of hyperbola, director circle of hyperbola, normal of hyperbola, pair of tangents from an external point, chord of contact, equation of chord in terms of the middle point, and finally the rectangular hyperbola, and that will conclude our discussion. And all these topics we will be discussing in the next few classes. So with this note, I would like to conclude the class here, dear students, unless you have any specific question for me. Thank you.